Hi, my name is Nancy Sanders, and what I'm going to talk about in my project is a microalgae lamp. And what I'm going to talk about is what is a microalgae lamp and its concept, the carbon background, the inventor of the microalgae lamp, how the microalgae lamp works, and display a few applications and the benefits of it, and a little small demonstration afterwards. What is a microalgae lamp? Basically, it's a lighted system that requires no electricity for power, but draws CO2 from the atmosphere and uses it to produce light as well as oxygen as a byproduct. As we all know, CO2 is most well known as greenhouse gases. It simply is a byproduct of burning fossil fuels such as gasoline, methane, and propane. The greater number of these heat-trapping molecules exists, the more the Earth temperature will continue to rise. Trees naturally eat carbon dioxide, but on a per tree basis, they don't consume as much, only about 1 ton their lifetime. In order to keep these numbers of heat-absorbing molecules down, we need more CO2 eaters here on the Earth. So a French biochemist, Pierre Carlisle, just spent several years developing a lamp that feeds on a huge amount of carbon dioxide. The key ingredient to this lamp is a single-cell algae known as microalgae. Microalgae, unlike any other crop on the earth, microalgae can be grown and cultivated in extremely adverse conditions. Also, these microalgae can produce more biofuel than comparable energy crops, which makes it a target for most of the research work on the future power sources. So how does it work? Well, the lamp consists of a tube containing microalgae-filled water as well as a battery system on the bottom. The lamp can charge during the day through photosynthesis and then driven by the sun and the nutrients. The stored power is then used as at night to power the light. And I'm going to show a few applications how this microalgae lamp can be used. Scaled properly, the lamp can be used in indoor spaces as well as in indoor garages. Also, it can be self-powered microalgae street lamps absorbing CO2s from the cars. Additionally, it can be used as an air purifier, display piece, and lighting in shops. So I tried to find a few other designs out there as a microalgae lamp since this new discovery, and in a few slides I'm going to show a few of different applications, different type of styles. This is a blown glass type of microalgae lamp, and you can see the water and carbon draws in. There's a little battery source here. And also, there's an LED that kind of lights the algae lamp, allows it to grow. And I'm going to show the screen how it is applied. Here's the blown lamps during the day, and it illuminates at night. Here's another design that I found also. As you can see, the CO2 goes in and the O2 comes out. It's clean air. And this could be displayed in multiple areas, as you can see in the streets. This is another type of design called a lateral algae lamp, designed by Mike Thompson. Its electrical current is drawn in from the algae during the photosynthesis, as the other microalgae lamps are. Of course, the algae only needs sunlight, carbon dioxide, and water to survive. So placing the lamp outside and breathing into the lamp begins the energy production process. The energy produced is stored in the little battery that's on the bottom here, which can be used upon at night. And this next one I thought was pretty wild. I know it's not really a lamp, but it's more like a microalgae design. It's an exhibit called the Hort. And basically it's called a hydroorganism responsive to urban stimuli. It's a London-based studio called ecologic that creates a little sci-fi greenhouse is which 325 transplant photobioreactor bags containing 9 different species of algae. The bags are attached to clear plastic tubes in which visitors can blow in and assist with the oxygenation and growth of the algae with their very own carbon dioxide. So basically, what are the benefits for a microalgae lamp? A microalgae lamp not only produces light but also consumes CO2, as we talked about. The lamp releases light energy stored in the battery only when needed. It produces any eco-friendly byproduct oxygen. Only microalgae lamps can suck in up to 1 ton of CO2 per year, which means one lamp absorbs as much as CO2 in 1 year as a tree does in its lifetime. An entire city can be equipped with these green lamps, will have the ability to absorb enough carbon dioxide equivalent to that absorbed by a big forest. Another key benefit of these lamps is algae can act as a biofuel when separated from the water. Hence, every time the water in the lamp needs changing, the water algae can still be used as a fuel and water can be recycled to use for other purposes. So a little after this, I'm going to show you a demonstration how I see how carbon is a key essential for growing algae and how it produces a little current.